skewness. A box plot can often be used to identify skewness. If you remember, skewness is how much the graph is skewed to the left because we have a longer tail on the left, or skewed to the right because we have a longer tail on the right. Here, we have more data on the right. Here, we have more data on the left. A distribution of data is skewed if it is not symmetric and extends more to one side than to the other. Elements of a box plot. Number one, a rectangle or the box is drawn with the ends, sometimes called the hinges, drawn at the lower and upper quartiles. They're calling it QL and QU. We're calling it Q1 and Q3. The median of the data is shown in the box, usually by a line. The median is Q2. The points at distances 1.5 times IQR from each hinge mark, the inner fences, is the data set. The lines, sometimes we call them the whiskers, are drawn from each hinge to the most extreme measurement inside the inner fence. We have a lower inner fence, Q1 minus 1.5 times IQR, and the upper is Q3 plus 1.5 times IQR. A second pair of fences, the outer fences, appear at a distance of 3 times IQR from the hinges. We haven't really dealt with that. They're even more of an outlier because they're further away from the rest of the data. One symbol, for example, this asterisk, is used to represent the measurements falling between the inner and outer fences. And another, 0, is used to represent measurements that lie beyond the outer fences. Thus, the outer fences are not shown unless one or more measurement lies beyond them. If they fall outside of 3 times IQR, we don't even show it. It's just too far out. Symbols used to represent the median and the extreme data points, those beyond the fences, will vary with the software used. Now we're going to look at how you interpret the box plots. The line or the median inside the box represents the center of the distribution of data. That's what the median is. Examine the length of the box. This is the median. That means from here to here. What do we call that? We call that our IQR. And it's a measure of the sample's variability, and it's especially useful for comparing two samples. Why does it measure its variability? Because the wider it is, the more the data is spread out. Let's say this is 15 and this is 65. Those are separated by 50 points. That means the data is spread out a lot more than if I were to change this to 3 and 8. If this is Q1 and this is Q3, then 50% of our data falls between 3 and 8. Whereas the other one, 50% of our data falls between 15 and 65. That's a big difference. This is Q1 and this is Q3. If you look at it on the line, Q1, 25% of the data falls below it. Q3, 25% of the data falls above it. That means 50% is in that region, or our IQR. Visually compare the length of the whiskers. If one is clearly longer, the distribution of the data is skewed in the direction of the longer whisker. Analyze any measurements that lie beyond the fences. Less than 5% should fall beyond the inner fences, even for very skewed distributions. Measurements beyond the outer fences are probably outliers, with one of the following explanations. We have our box plot, and then we have these outliers. Why do we have outliers? We may have made a mistake when we measured something. It may have been observed, recorded, or entered into the computer incorrectly. That's always a possibility if we have something that's doesn't make sense that it's in our data set, you may want to look again and see if there's a mistake. B, the measurement belongs to a population different from the population that the rest of the sample was drawn from. Let's say I was measuring Labrador retrievers. I wanted to know what the smallest, what the biggest, how much they vary, and somehow a poodle got in. It would skew the data. It may have gotten in there by accident. Or the measurement could be correct and from the same population as the rest of the sample. Generally, we accept this explanation only after carefully ruling out all others. If you see outliers that don't make sense, you want to look at the values and see where they came from and see if they came from a viable source. If you find an error in how you measured it, or you find that it wasn't even supposed to be in our sample, those are two possibilities. You always want to look for that first. If you don't see any problems, then you just have some outliers. Thank you for watching.